I'm Dr. Littman. You can call me Mike, Yo Fatty, any of those work. I'm not a formal person. You can call me whatever you want. Um, for most of you, this is going to be your first experience with computer programming. Computer programming is well. First of all, let me cover it from this perspective. My PhD is in computer science. You guys are taking a master's program in information technology. Okay, I view the two disciplines as different sides of the same coin. What I tell people is I say computer scientists create, IT professionals apply what's been created. Okay? Now, there's obviously overlap between the two. So let's call it 70-30. 70% of the time, computer scientists create, 30% of the time they apply. IT people, 30% of the time they create, 70% of the time they apply. So programming is actually a very important skill when it comes to the IT profession, because you're going to be writing all sorts of scripts for creating users and backup. It is a very important skill in the technology field. Okay, so one of the difficult things people have with computer programming, it's a very tough discipline, I think, to teach for one hand, but on the other hand, it's hard for human beings to learn how to program, and it's not because we're stupid. It's because we're too good. For example, the question I always ask is, so y'all walked to class today, right? How many of you bumped into a wall on your way to class? Not Professor Wall, just a wall. Okay. None of us, right? You all missed all the walls? How? How many of you, when you were walking down the hall, how many of you actively thought about, oh, I don't want to hit a wall? No. You walk all the time, right? You've gotten pretty used to not slamming into things, right? How many of you have ever texted and walked at the same time? Texted, on your phone? All the time, right? You're probably pretty good at that too. You just need a little vision over there, and you can make like quick little turns at the last second, right? Okay. So all of you magically got here today without slamming into a wall. Yet, if I asked you to tell me how you did that, you would have trouble. Try. Explain to me. Let's say I just started walking. Okay, just got up on my feet. I'm ready to walk down this hall. How do I walk down this hall without slamming into a wall? What instructions would you give me? You're my coach. What do you think?
Stand up and walk into the path.
Okay.
Which you regularly do. You have like many choices on that.
Okay, well let's back up for a second. I'm already standing up, and now you want me to walk. What does it mean to walk? How do I walk?
You use the same thing which you do every day.
No, but say I just started. I don't know how to walk. I just started. So you're gonna have to teach me how to walk first. How do I walk?
Step by step.
Okay, what does that mean? So I'm standing there. I'm a little top heavy, so I'm wobbling around. It's like, oh, you can walk, no problem. Just go step by step.
Yeah.
And I, like a monkey doing a math problem. I don't know what I'm doing. What do you mean step by step? Give me some more detail.
You have to stand.
Okay, I'm standing. I'm already standing. We'll assume that's my starting point. I won't ask you to teach me how to stand. Okay, so I'm standing. Now what?
Think about it.
Okay, think about what?
How to walk.
Well, I'm asking you to tell me how to walk.
See your road.
Okay, see my road, see my path in front of me. Okay, so I'm looking ahead, and I've picked a target. I want to walk that way. All right, so how do I walk?
Move your legs.
Left.
I'll just move them.
Yeah.
All right, so I just stand here, just start. Let's just. Is that it?
You can Google it.
I don't know how to walk, but I know how to Google how to walk. This is difficult, right? Yet all of us in here can walk, correct? Yet it's difficult to explain to somebody how they walk. In another class, I had somebody say something which is substantially better than what you guys are doing. It said, shift all your weight over to one foot. Then swing the other foot forward, the one that doesn't have the weight on it. Then while it's still in the air, shift all your weight towards that one, which then causes you to fall forward. And then you catch yourself with that leg. And then shift all your weight to the other foot, back and forth. Isn't that how you walk? Isn't walking essentially falling forward and catching yourself over and over and over again? I mean, those were way better instructions you guys gave me. I got stand up, think about it, then Google it. Point here being, when we think about telling computers how to solve problems, which is kind of the punchline of computer programming, that's what we're trying to do. We're trying to explain to a computer how to solve a problem. We need to treat that computer like it's dumb. It doesn't know anything. It has no preconceived notions. It doesn't know how to walk. It doesn't know all the little steps that are taken. So you have to specifically spell out everything in a completely unambiguous way. And that's very difficult for human beings to do. Why? Because we're so good at problem solving. There's so many things that we do every single day that they become so trivial for us that we don't know how we do them anymore. It's the reason why learning how to program is kind of a difficult task. It's because you have to retrain the way your mind works. You're training your mind to work in such a way that you're teaching an infant how to do something, which is very different than the way we're used to operating on a daily basis. Okay, so in order to slow our brains down, we have to think about how do human beings solve problems. Okay? So and this is just kind of my version of this, I say human beings really solve problems by using three different tools, three different power tools. We use our memory, we ask questions, and we repeat stuff. Now, you probably could throw some additional things in. I just tried to kind of keep it fairly simple. But think about it. How important is our brain? How important is our memory to solving problems? How debilitating would it be not to be able to remember things? Extremely, right? I mean, when you see these movies, it's something they make fun of in movies with the short-term memory loss, where somebody walks in the room, introduces themselves, and 30 seconds later, it's like, "Oh, hi, how are you? I'm Mike." And yeah, we just met. Well, not to me, we didn't. I've already forgotten you. Well, but when you really think about it, it's a very debilitating thing. So, it has the humor side in movies, but in real life, diseases of the mind actually are amongst the most debilitating. You'd much rather have your full mental faculties and not be able to walk than be able to walk and not know your own name. At least I think that's probably would be a preference for everybody. Yeah, probably. Okay, so any way you cut it, memory is important. Okay? Asking questions. Having the ability to ask a question and getting a response is something we do all the time. When you were walking down the hall, not running into the walls, you were asking questions. You didn't realize you were asking questions because it comes so naturally to you, but you were constantly saying, am I about to bump into something? Am I about to bump into something? If the answer is yes, I need to do something about it. I need to react. I need to shift my weight so I start banking forward or whatever it is. I need to constantly be asking questions whether I'm about to smash into something. Okay? At the same time, I'm also probably asking questions like, am I about to lose my balance? Is all my weight on my left foot? Is all my weight on my right foot? Am I about to fall over? How does my hair look? All at the same time, right? So asking questions, very important. Repetition. Repetition, and human beings do this all the time. We find something that we do, and then we repeat it over and over again. Walking is the same thing over and over and over and over and over again. Okay? So repetition is an important thing for problem solving. Human beings tend to, this is all actually really the whole supply chain management type of concept where we like to pick we like to set things up in a certain order such that we do this, then this, then this, then this, then this, and the job is done. And you go back and do it again. Okay, that's how human beings like solving problems. Okay, so now this is how we as people solve problems. One of the jobs, well, let's just say the main job of a programming language is to give us a tool for communicating to a computer the solution to a problem, hopefully in terms of things similar to these three. So a computer programming language is attempting to simulate the way we solve problems in real life. All right? And the way this is done, this is the provides humans with a means for communicating with the computer, just said that. Now, why not English? Because English is imprecise. Any language, any human language is imprecise. So pick your native language, whatever you want to do. Human language tends to be very imprecise. Human languages, like English, are not, they're not geared for talking unambiguously. By definition, they're very ambiguous. I mean, people misunderstand each other all the time, right? That's part of what makes those languages powerful, is because we are able to express ourselves with a lot of gray area in the middle. Not going to work for talking to a computer. So we need to have something that allows us to communicate to a computer unambiguously. All right? Computers do exactly what we tell them to do, so our instructions need to be unambiguous. Okay, so in a computer programming language, whatever language that ends up being, and we're going to talk about the different languages here in a few minutes, there is a conversion. I said a few minutes ago that one of the goals of the computer programming language is to simulate the way we solve problems in real life. Okay? So what we do is we simulate the concept of remembering things, our memory, through something called variables. Okay? For those of you who haven't had programming, if you've had math before, we have variables in math all the time, right? X plus y equals 5. X and y are both variables. Okay? Asking questions. In a programming language, these come in the form of something called conditionals. The most common of which is something called an if statement. Okay? Repetition, we accomplish these through something called loops. Most programming languages support 3 different kinds of loops. A for loop, a while loop, and a do while loop. And we'll talk about each of those and what they mean, blah, blah, blah. But the point is that your typical modern programming language supports structures that facilitate equivalence to the way human beings solve problems. Memory, asking questions, and repetition. With the hope being that once we get past the new language part of it, that there's this weird syntax that's going to be very new for us, once we get past that, we are at least left with a tool that allows us to solve problems similarly to how we solve problems as human beings. Then we just have the uphill battle of slowing our minds down to the point that we can actually tell the computer what to do. Because we already saw teaching me how to walk failed miserably. Okay, so we need to really practice on slowing ourselves down. Because human beings have gotten so good at problem solving that we get so far ahead of ourselves that we forget about the baby steps that it took to get there. So we need to slow ourselves down and break every problem, the solution to every problem, down into its tiny little baby steps that it took to accomplish it. And at first we're going to feel like that is not a waste of time. We're gonna feel that it's aggravating to have to do that until we realize that our programs will never work unless we do. So early on, we're gonna have to really map out everything we ever do programming. Eventually, your mind starts working that way naturally.